Hello and welcome back to another week of Whether or Not. I'm your host, meteorologist Scott Sumner, sponsored by Ford. This week, I'm talking from the East Coast to a gentleman way on the West Coast. I'd like to bring in right now research geophysicist or geologist, Jonathan Hagstrum. Hello, how are you, Jonathan? How are you doing today?
I'm fine, Scott. How are you doing?
I'm doing pretty well here at this hour. Though we have some flooding around the region today, so we'll be talking about that later in the weather. But I wanted to talk, about some of the interesting things. You know, when I try and find guests to come on my podcast, obviously I'm trying to tie it in some sort of weather connection. And I was reading up and I came across your page, and you are a geologist. But how did you get interested in bird navigation? And there is a reason I am asking that.
Yeah, well, I started out as a biology major in college. I wanted to be a naturalist, and but those were all that major was geared toward pre-med, which I wasn't interested in. So I took a geology class, and I loved it. I had a great professor, so I became a geology major. And then on my senior year, the geology department had a seminar every Friday. And this Friday, my senior year, the guest was a biologist from the biology department, a man. I was at Cornell, and the man was Bill Keaton, very famous animal navigation researcher. And he gave a talk on his pigeon releases and his studies around the Cornell area that he was doing, trying to understand how pigeons were able to navigate back to their loft so quickly and so accurately. And I was just fascinated. I thought it was just the most incredibly interesting topic that I'd heard about. So I just tucked that back in my mind. And then late in my career, I started thinking more about it. And I actually started to do some work on it. So that's how I ended up here.
Yeah, and this is a whether or not podcast, so that's why we bring up birds and animals in general sometimes, but specifically in this case, birds. They use the weather and the pressure, the atmospheric pressure out there to kind of help themselves. And they sometimes know a little bit more than we do beforehand, a little earlier here, of what is happening. So I have read that birds use the Earth's magnetic field to navigate. Okay, so is this true? And if not, how do they find their way?
Well, it is true in part. Just like humans, animals, in order to navigate, must have some kind of map ability and some kind of compass ability. And we use the magnetic field as a compass, and so do many animals, and in particular birds. But birds also are able to look at the sun and use that as a compass. They have a sun compass, which is time compensated by their circadian rhythms. So they know what time of day it is. They can look at the sun and they can get a compass direction out of that. Night migrating birds use the pole star just the way we look at it and go, that's north. But the problem has been, so the compasses are pretty well understood in terms of what birds are using and other animals. But the problem has been for as long as people have been studying it is, what is the map? How do they know where they are relative to where they want to go in order to pick the right compass direction? So biologists have sort of thought, well, maybe they also use the geomagnetic field as a map. And that's part of what I studied during my career. And I just couldn't believe that. And the other idea biologists had was somehow they use trace odors in the atmosphere blowing around. And I just like, that doesn't make sense to me either. So later on, I read that birds, pigeons in particular, could hear very low frequency sound, which is called infrasound, only because it's lower than what humans can hear. So I started looking into that.
Fascinating. And on that subject, you're right. Birds have the ability to, obviously because they're flying, to see the sun, to see the stars for navigation. I also had heard, and this is a little off topic, but sharks, because I'm a shark enthusiast, especially about great whites, that they also, when tropical systems move across the ocean, obviously the pressure is much lower. They actually dive thousands of feet down or hundreds of feet down below where they would normally be. So I guess all animals, whether they're above or below, seem to use some sort of navigational system, sort of a compass there.
Right. Well, sharks also use the magnetic field as a compass. But the one thing I've learned, Scott, in studying animals, and it was why I sort of was originally interested in biology, is, they've been evolving just as long as we have. So we have these like fantastic brains, which we think are so amazing. Well, birds have been, evolving for 100 million years more. And they've had to evolve to be able to really fine tune themselves to their environment and to learn to do things that help them survive. And so animals can do just amazing, amazing things. So I always have the highest respect for them. So yes, I agree with you, Scott. They know a lot more than we do.
Yeah, absolutely. Yeah, exactly. Hey, I'm going to circle back now, Jonathan, to the pigeons, because you talked about them just a little moment ago. Now, you wrote about pigeon races being affected by sonic booms from the Concorde SST, which is sea surface temperature, if I'm not mistaken.
No, that's supersonic transport.
I'm sorry, supersonic. Right. I see SST.
Yeah, the plane. The supersonic plane.
Plane.
It's not flying anymore, but this is sort of dating how long I've been working on this. It crashed in Paris in 2000, and they stopped flying it altogether in 2003.
That's right. Yes, I remember that. I'm so used to seeing SST, sea surface temperature. My bad. What did
no problem. I understand your problem.
My question for you, though, is what did this tell you about bird migration?
Well, the thing I was telling you, I started thinking about infrasound, and I'm sitting there, and I don't have any data. I have lots of geophysical data, but I don't have any access to sort of bird data. And I might just mention that people have studied pigeons because they migrate on demand. Most wild birds, you'd have to wait every 6 months because they migrate one way in the spring and another way in the fall. So, but pigeons, you can take them out away from their loft, and you can do all sorts of things to them, and they can find their way back. And you can take them places they've never been before. You can put them in all kinds of, boxes and cages and things to try to keep out any cues they might have that would give them some indication of which way to go. And they still can just no problem find their way back. So they're also domesticated, so they're easy to keep. So they are the subject animal. So most of the studies of animal navigation has been done on pigeons. But there are also people that race pigeons, and they do it all around the world. And I think, in China, they sold a racing pigeon stud for like a couple $1 million. So it's a big deal. And but anyhow, I'm sitting there like I had read that pigeons could hear very low frequency sounds. And since there are not that many senses, they'd already ruled out most of them. It was like, well, maybe this could be what they're doing. So what do I do? So I read about some pigeon races. I read about it in the local newspaper, that some pigeon races back in Pennsylvania had been what the racers call smashed. In other words, the race was smashed, which means they had let the pigeons go. They expected them back within a certain time. Like running a race, you have some idea how long they're going to take. And the pigeons didn't show up. And it was a beautiful day and everything else, and nobody could explain it. So I thought, if this infrasound idea has any merit, maybe I can find an infrasonic source that disrupted these races. And to make a long story short, it turned out to be the sonic boom off the Concorde.
How long does a basic, how long does some sort of, project take? Are we talking, days, months, weeks, years? How long would something like that take?
Are you talking about
research?
What sort of project? I'm not sure.
With research with regards to, okay, I want to find out, exactly about bird navigation, as you just talked about here, and the infrasound, and and how they migrate and stuff like that. How long does something like that take? How long a period of time would something like that take to kind of say, I want to do this, and I want to come up with some sort of thesis, whether good, bad, or indifferent, upon my research?
Right. Well, that's a good question. Most of the work is done at universities by students with their professors. So if they're doing a master's degree, which would be sort of a more basic project, that could take a couple years. If they're working on a PhD on more basic research, a more difficult problem, that could take, anywhere from 4 to 8 years. For me, this is not my day job. So I was working as a geophysicist for the U.S. Geological Survey. I'm retired now, but I worked there for 41 years. And so most of the time I was doing that. And just every once in a while, I'd read something about bird or animal navigation, and I'd write it down or think about it. And as I said, it wasn't until toward the end of my career, when I was sort of, wrapping up, I started thinking about, well, wait a minute, maybe I should look into this a little bit. So I did it in my spare time. So as I say, I started working on it in 1998, and I'm far from being done. So it can take a long time.
It sure can. Now, we all heard about the theory that crickets, a cricket's chirp can calculate the temperature, with the formula, and you add 40, you do this, that, and the other thing, which I find fascinating. So what about birds? Are they able to kind of predict the weather?
Well, actually, I've read a lot. And a lot of people that work with birds call them weather prophets, and they do seem to be able to tell what's coming, but in a more scientific way. I think what they're really doing is they can hear the weather far away, and whether it's coming their way or not. And let me just give you a really, really cool example. There's a bird called the bar-tailed godwit. And it flies from Alaska. It migrates from Alaska to New Zealand, nonstop.
Wow.
And it takes it about a week to do that. And it starts out on the Yukon Delta, where it's very rich in food, and it fattens itself up to the point where it can barely take off. And when it finally gets to New Zealand, it's out of gas. It just barely makes it. And the thing that it can do is that it doesn't leave for this migration until the weather conditions along the entire length are favorable to it. In other words, if it had to face a headwind the whole way, it wouldn't make it. So it doesn't leave until the weather conditions are favorable. So how does it do that? Well, the thing is, infrasound moving through the atmosphere depends primarily on the temperature of the air and the winds. So I think, I haven't proved this, but I think that not only are these bar-tailed godwits using infrasound as a signal to navigate to New Zealand, but they're also features of this signal. They're characteristics of this signal that they can tease out and go, the wind conditions are good, so I'm going to fly now. So
kudos.
It's mind-boggling.
It truly is. Kudos to those birds, and they do this every year. They go
every year,
from
and
Alaska.
Then they fly to China, and then they fly back to Alaska.
Unbelievable. Well,
it's just crazy.
It is when you think about it. Now, you did mention just a few minutes ago you're kind of retired, but what's next? I mean, you don't seem like a person that can rest on the laurels, sit back, and just do nothing. You seem like you want to be active and so. So is there anything in your future here?
Well, Scott, now that I'm retired, I can finally spend full time working on this. It's no longer going to be my, my moonlighting. And so, yes, I have a whole list of papers that I want to write. The one I'm working on right now is I've gotten a bunch of aeromagnetic data from one of my colleagues who's studies the Earth's magnetic field in detail. And I'm using those data to show, I think, pretty clearly that you cannot use the magnetic field as the map. And then the next paper I want to write is that you can't use the you can't use odors as a map. And so, I've also been writing papers. I have a number of studies on data that I was able to collect from Cornell. It's kind of ironic that unfortunately Bill Keaton, the guy who originally gave the lecture that I heard as a senior in college, and I'll date myself, this was in 1976. He died prematurely, very unfortunately, but he was very collaborative. So his students and his colleagues decided to make all of his data available. And he had an army of students. He had a loft at Cornell with 2,000 birds in it. And he was collecting data hand over fist, but he never got a chance to publish it all. So it's an incredible gold mine for someone like me who doesn't have any data. So I've been writing papers using those data, and I have a number of more that I want to write. So, you know, for the next, I don't know how many years, I'm going to be writing papers.
Where can they find this information? When you finalize everything here, Jonathan, and some people are very interested in this stuff, where would they be able to find your papers and your research?
Well, they're going to go into biological journals. Probably the best way to find out more about it would be to, you know, just Google bird navigation, my name, infrasound, things like that would come up.
Excellent.
I spell my last name Hagstrum. So that's I think the best way to find it.
Absolutely. Well, I hope people that are watching this and have some interest do turn out and start reading some of your work, and certainly bring some light to some a very interesting topic that I thought of and why I wanted to bring you on my Whether or Not podcast today. So I really do appreciate you getting up early, out West Coast time, and coming on board and talking about something that interests you. It certainly interests me, and hopefully interests others out there.
Well, thanks a lot, Scott, for having me. It's been a lot of fun.
You're very welcome, and have a great rest of your day and week ahead. All right, well, that again was Jonathan Hagstrum, research geophysicist, retired, but still working out there. All right, well, that's all for today on our Whether or Not podcast here in the DC studios. Thanks for joining in. Obviously, God bless, be well, and stay safe. See you soon. Okay, Jonathan, have you